So more loops. Define a function my index of that accepts 3 arguments. Okay, so not 2, right, but 3. The 3 arguments are source, a search value, and a starting index. Okay, and the third one is optional. It's pretty interesting. And so, okay, if the source, right, contains the search value, return the index at which the search value starts. If the search value appears more than once in the source, right, return the index from the first occurrence of the search value. If the search value doesn't exist in the source, return -1. Okay. So what does this mean? Let's just go down here. So basically, right, we're trying to find a needle in a haystack, right? This right here is a haystack, okay? And I want to find the needle. And I want to say, hey, is H in this source? Is the thing that I'm looking for in this source? And if it is, right, return the index of where H exists. So it's 0, right? Where's E? E is at the first index, right, etc. And then in this situation, you have twice, right? And you're trying to find ice. And so it actually appears a couple times, right? But what does the question say? The question says, if the search value appears more than once, return the index from the first occurrence, right? So ice appears twice. So you're like, where do I put this? Well, you want to give the first occurrence, right? So the first time ice appears is actually here. And where does that start? It starts here. At the second index, right? 0, 1, 2. So you return 2. Does that make sense? So in any of these situations, you're just trying to find this in this. The first occurrence and the first index at which it occurs. And then optionally, right? Find the index of the first instance of ice starting. Okay, so if you have a third argument, right? That's basically saying I want you to start looking from this index. So 0, 1, 2, 3, 4, 5. So we're gonna start looking from here. And it's as if like none of this exists. We're gonna start looking from here and go this way and see if we find ice anywhere. Okay, we found it. So that's the index we get back. Does that make sense? So if you give no third argument, right? You're not giving a starting point. And so we're going to assume your starting point is the beginning. And we're going to search from here. This is saying, okay, I don't want you to look at anything that's before index 5. I want you to start index 5 and then look this way. So and this is kind of like a bonus, right? This isn't as important as like this, I think. And then finally, right? If you can't find this thing in here, you want to return -1 just by default. Cool. Okay. Are there any questions about kind of like what it's asking? Just like what the question's asking? Cool. So we're given 3 strings, right? Or actually, let's pretend like there is no third argument. Let's just pretend like we're just working with 2 arguments, okay? So let's do something like this, E. So we're gonna say, let's use arrow functions, const my index of equals parentheses and then fat arrow and then curly braces. This right here is a valid function. I can run this and it'll be fine. And then we'll do this. And then in these parentheses, we want to put the arguments that we expect. What is the user going to give us? The user is going to give us hello and E, right? So you want to basically come up with like nicknames for what you're expecting them to give you, right? You don't want to put like hello in here, right? Hello is what they're going to give you. And so you need like an alias for that. And you can call that source, right? And then what is E? E is the thing that you want to find in here. And I think they call it like the search value, right? But I think what I'm going to do is I'm going to do needle, or I'm going to do haystack, and a needle. Whatever makes sense to you, right? Because this is the thing that I want to find in here, So do whatever makes sense to you. Okay. Cool. So let's go ahead and look for the needle in the haystack, right? And when you're looking, you want to start from the beginning, right? So say for let I equals 0. And so what does 0 stand for? Sorry, my throat's messed up. So 0, right? 0 stands for, represents an index. Which index? It's the 0th index of the haystack. Exactly. And we're going to increment. I'm going to start with the letter H, right? That's what 0 represents. And then go through each character one by one. And so we're going to go until we reach the end of the haystack. And how do you represent the end of a string? Where's the end of a string?
Length.
String.length. Excellent. Yes. Say string.length or haystack.length. Right? So start at the 0th index of the haystack and then go until the end of the haystack. So start at H and then go until O. Okay? And then I++. And here what I'll do is I'm just going to console log what I is. What is I? Just a bunch of numbers, right? This doesn't really look like HELLO, but that's okay. This is very close. What this represents is all the possible indexes, all the possible indices of this word. So what that means is, if I do this, no Siri. These numbers, the indexes, are like corresponding to each character in the string. So this is really helpful. Okay, and if I put a bunch, right, hello, it's gonna give me all the indexes in that string, right? That's pretty useful. So we can take this, and since I is an index, it's a number, I can use it to index into the string. Like this. Oops, like this, right? Haystack at I. So what does this literally mean? This is like hello at 0. And then hello at 1, and hello at 2, etc., right? So let's just console log this. Great. We get all the characters, right? Cool. So now what we want to do is we want to see if any of these characters, right, match up with needle. Okay, so I'll say, and what I'm going to do is I'm going to take this, I'm going to assign it to a variable. I'll say let character equals this. What does that mean? That means I'm going to get a letter from haystack. I'm going to assign it to something called char, which stands for character. And if I just console log every character, there should be no difference. I'm literally just logging each character, right? And then what we'll do is we'll say if the character is the needle. If any of these characters is equal to the needle, this letter E, right? Then what should we return? The current index. What is the current index? I. Exactly. Great. So as soon as we find the E, as soon as we find a match, we return I, which is the current index that I'm on, which is 1. And then what does return do? Return kills the for loop, right? It's like an emergency escape. We don't go through the rest of these. As soon as we find a match, we're done. And JavaScript will be fine with that. Even though you think the for loop isn't done yet, we made it finish by just doing the return. Okay. Now let's say we look through everything and we don't find it, right? Let's say I do HF LLO, right? We never found it. And so what should we return by default if this doesn't exist in here? -1. So we're going to put that at the very end. So what does this mean? This means if I go through the entire haystack and I never trigger this if statement, then that kind of implies that I haven't found the answer. And if I haven't found the answer, the question says return -1, right? That's just like what the problem's asking. So great. We got -1. Does that make sense so far? Yes.
When would you use a break versus return I?
Good question. So, return and break are similar in the fact that return will break you out of the function, just like the word break, right? Now, the difference is return actually gives back something, right? Return actually gives back something to the original user. Break just prematurely kills the for loop, but nothing's ever returned as a result. So if I say, okay, I found the needle, and I just break here, what is that going to do? We'll put the E back in. So what does this do? We found the needle, E, and then we break. So the for loop is over, right? So the for loop is done. Have we returned yet? No, we only return if we literally use the word return. We've just broken. So this breaks, and then we go down here, and then we return -1. But -1 is not the right answer, right? We broke at the right place, but we didn't return the right thing. And so here we just want to use return. Does that make sense? Yeah.
Why won't it return -1 then?
Why won't this return -1?
Yeah.
Good question. Because this basically, like, as soon as this for loop hits the word return, right? It doesn't matter that there's a bunch of other code down here. It's just immediately done. It's immediately done. How do you know for sure that it's immediately done? Because this, you don't see the rest of this log, right? LLO, right? So that's done. And so if I put a const log here, right? We'll say we search through the whole thing. We don't even see this show up. We don't see this show up because this runs twice. We find the E, we return. That means I'm done with the function completely, forever. And I'm not, even though there's more stuff to do, I don't care about it. I'm just gonna ignore it. It's an immediate emergency exit. Yes?
I have a question about if else.
Yeah.
We don't need to do the else statement before that return -1 because of where that function is.
So you're saying something like this?
Yeah.
Yeah. Okay, so that's a good question. So if you see an if statement, right? That it's not necessarily going to be the fact that you're going to have to use else also, right? So if you see if, you might be like, oh, I have to use else, right? The reason you don't need it here is because, okay, let's say if you find a match, right? You find a match, you're going to return the index, right? That's a given. If it's not a match, do you want to like return anything? Let's start with the beginning, right? We're starting with the letter H. Are H and E, are they the same thing?
No.
No, they're not. So we're going to go in here. Okay. Now that we know that they're not the same, do we want to do anything? Do we want to return anything?
No.
No. Right? You might want to return like -1 here or something. But like, that wouldn't be good because we would basically like realize that E is not H, and then immediately say, okay, E is not in this whole thing, right?
Yeah.
We want to make sure to go through the whole thing, right? It's like, so if I do this, return -1, then we're going to return, we're going to say, oh, H is not E. So therefore, E doesn't exist in here, and I'm going to return -1, right? We don't want to do that because we haven't looked through the whole thing yet. An analogy for this is like your friend says, hey, can you help me find something really important, right? And you look in one place and you're like, oh, I didn't find it. I'm sorry, right? When do you want to return? You only want to return within this for loop as soon as you find something. That's the only case where it's okay to stop searching prematurely, right? Your friend's like, hey, help me find this, and it's like a 10-bedroom house, and on bedroom number 2 you find it pretty early on. Like, why look at the rest of the house, right? As soon as you find it, you can just exit. Does that make sense?
Yeah.
But just because you don't find it earlier on, you don't want to exit. Does that make sense? Okay. And finally, we can put this down here because we're only going to get to this line if this entire for loop is done. If you search through the whole house, then you pass and you get to here and you're like, okay, I didn't find it anywhere. I promised I looked in every possible corner, right? But I didn't find it, and didn't find it is just represented with -1. But really good questions. Any other questions? Okay. Yeah.
The let character equal haystack I.
Yeah.
Could that come before the loop?
Ooh, something like this. So the reason you can't do this is because I is defined after this line,
Oh, right.
right? So this I is a variable, and this isn't defined up here anywhere. It's defined underneath it. Good question. It's like the equivalent of doing something like this, where I say like console log num, and I say num equals.
Right.
We can't do this. It has to be after the definition. Yeah, great question. Okay. So I guess this actually doesn't really solve the complex case here. We're trying to find ice, right? This. So this is a tough problem. Who got through this? Nice. I think you have to use like do you have to use a double for loop?
Okay.
Oh, that's horrible. Okay, so just for the sake of time, I'm just gonna walk through what. Yes.
Sorry. In the video solution.
Yeah.
Slice.
Slice and dice.
Yeah. So that should not be allowed.
Okay. I made it really short, but I didn't know what slice was, so.
Yeah. No. That's exactly why it shouldn't be allowed. So we'll get to slice. That's coming in like a few lectures. But the general idea is like we want to find. So far we've been trying to find E in hello, right? And then now what we want to do is so basically we find a character H and we're like, is that H equal to E, right? And then we're like, is this E equal to E, etc. Right? The reason this is complicated is because we still have to go letter by letter. We still have to do each letter. So we're gonna say T. Is T equal to ice? No, it's not. Is W equal to ice? No. Is I equal to ice? No. The letter I and the word ice are different. Is C equal to ice? No. So we're going to go through this whole thing and realize we haven't found ice anywhere. When instead, what we should do, right? There's a few ways to do this, but what we should do is, as soon as we find that this I matches the beginning of this word I, we should then kind of like move in lockstep and say, okay, is the next letter the same? And then is the following letter the same? Does that make sense? And then if we reach the end of the string, and we reach the end, and haven't found like a mismatch yet, then that means okay, this exists in here. I know that's really confusing, okay? But that's one way of doing it. The second way, kind of like my preferred way, is to actually I think you have to use slice. Okay, yeah. So the first way is how you should do it, given what you know right now. So that makes sense. Like right now, what we're doing is we're going through each letter by themselves, right? H, E, L, L, O, and that only helps if there's only one character that you're looking for. But as soon as we're looking for more than one character, right? We can't go letter by letter anymore, right? Because ice isn't equal to any single letter. So we have to do it we have to use the first character as like our cue into, okay, let's start digging right there, okay? So we reach I, and that matches the first letter here, and then we look at each other one, okay? And then we'll see that there's a match there. If there isn't a match, like something like this, right? We'll say, okay, is I equal to I? Yes. Is C equal to C? Yes. Are these the same? Yes. Are these the same? No, they're not, right? And so this, we would not have found this here, right? That's not a match. And so we then carry on and look for ICER in the rest of the string. Does that make sense? Okay. Should I? Who wants to see this solved? Yeah, quick. I'm afraid that if I do go through and solve this, it might confuse you even more. But let's do this. We'll do this and say this is like one character, right? Works for one character. Okay. Oops. And then we'll do this down here. Okay. I'm looking for ice, right? So what we're gonna do is we're gonna say character is haystack at I, and what we're gonna do is we're gonna say I guess potential match, right? The potential match is going to be needle, right, at 0. So potential match as in what? As in I, right? Which is needle at the first index, okay? And so if the character, such as W or T or I, right? If that matches the first character of my needle, right? If they are the same, what do we want to do? I want to go ahead and start moving kind of in lockstep right here, okay? And so we need to do another for loop. Why do we need to do another for loop? Because we have to loop through each character in here and compare it to each character here, okay? So for, and we'll say let, we can't use I anymore, okay? Because I is being used here, so let's declare a new variable. Say let j equals 0. Because j comes after I, right? Why not? And we're going to go until j is less than needle.length. Okay? So we're going to move through each character in here, right? So here I'm going to declare another character, right? And I can't just say character because we already have a character here. So say let, I don't know, needle character equals the needle at j. Okay? So what does this mean? This means, so needle character is going to be I, and then C, and then E. Okay? And we'll say is, if, let's see. Okay, so needle character is needle at J. And then what is going to be the haystack character? It's going to be haystack, right? It's going to be haystack at I, and I'm really sorry, plus J. What does this mean? I right now is wherever we've found a match in the first character so far, which is 0, 1, 2. It's 2. I is 2. Okay? Well, what's J? J starts at 0. So what's 2 plus 0? It's 2. So that's going to be this I right here. Okay? And then let's say we increment J. J becomes 1. What's 2 plus 1? 3. So now we're going to look at the third index, which is C. And then we're going to look at E. Okay? So I is kind of like our baseline, right? I is kind of like where we're locked into this original string in the haystack. And then J is going to control us incrementing through that. Okay? And then we'll say if, right? If at any point, right, needle character and haystack character are not the same, right? What does that mean? That means like if I have something like this, where, okay, I found a match in these I's, and so I'm going to then look at C and compare it to B. And if they're not the same, which they aren't, we're going to return -1. Oh, we're not going to return -1 actually, because we have to keep looking through the other strings. So let's do something like this. We don't want to return -1 because IVE could end up here, so we want to keep going. So what should we do here? Okay. So we'll do this. Hold on a second. So I don't want to give you misinformation. So if the needle character, and there might be a better solution for this, if the needle character equals to the haystack character, as in if all these characters are the same, and then I've reached the end of the haystack, or the needle. I've reached the end of this word, right? And, but you haven't learned and yet. And, J is needle.length -1. then in here, you want to return the original index where we initially started, which is I. This might work.
Won't that return just I?
It would return I, which is what we want. That's not what we want, though. Hold on a second. Let me just console log this. Sorry, guys. I should definitely have prepared. Needle char and haystack char. Oh. Why is this not even running? If character equals, sorry, potential match. There it is. We never went into this if statement because I said, hey, is this character ever going to be the same as this whole word? Which is not what we want. We want to say, is this character going to be the same as the beginning, as the potential match, as the beginning of Neil? Then we're going to start our search. Does that make sense? I know this looks ridiculous, right? So there's got to be a better way to do this. I don't want to return I here. We didn't break. If I break here, if they're not the same, then break and then return. I'm gonna have to give you a better answer, but this is kind of like what I've come to. Any comments? Yeah.
It says we're allowed to use slice though. Wouldn't slice make it a lot easier than you just change
It-
the
You should absolutely use slice. You should absolutely use slice. I think the issue was you haven't learned to use slice yet, right?
They never teach slice though. Like
They taught slice?
they never teach slice.
They never taught slice.
It's just a problem 5 we solved for my slice, so that's why they like let us use. Slice.
Oh, I see.
The problem before this was my slice.
Got it. Okay. You should definitely use slice if you know how to use slice. I'm not gonna get into that now because we do go into it later with arrays and stuff, which can be applied to strings. I'm sorry, like this question and the very last question are just like really tough, given what you know so far. Yeah.
I had a friend help me out with this one. He did a function and he had a for loop that didn't slice, and then put that same function into the my index of and then use slice with there or something like that. He basically
Oh, okay.
had two functions and one was a for loop and then the next function was just another use a for loop.
Got it. And that inner function use slice or no?
I forgot. I mean,
Okay.
I didn't save,
So
it's
yeah.
using two functions.
So that's a good point. Like if you ever have a function that looks like as disgusting as this, you want to break it up into like logical chunks. And so like this block right here, right, is like I'm trying to find like I'm trying to go through each character in lockstep between the needle and the haystack, and that's sort of a different problem than like this outer for loop, which is I'm trying to find the first letter match, right? So what you might do is take this functionality, put it into a different function, and then run that function in here. Definitely don't have to do that, but it definitely helps. Okay, I am